Hey guys, this topic is linear programming, and it's another optimization technique. In linear programming, what we're trying to do is maximize our profit under circumstances of constraints. We're using the actual problem that's in the topic now. And what that means is that I've taken the basic data from the problem that's in the mod, and I've summarized it here. What we're looking at now is Delta Outfitters, and this company, Delta Outfitters, makes togas and dresses for fraternity parties. Togas require 5 yards of material and take 3 hours to make. Dresses require 4 yards of material and take 5 hours to make. Then the gross profit when we sell a toga is $55. So I don't know, maybe we sell it for $100 and our cost is $45. So the contribution margin then is $55. Same idea for dresses. So these are contribution margins or gross profits on each one of these two products. Okay, so the idea is that we have certain constraints, okay? The maximum number of hours that we're allowed to use, okay, is 500 hours. And the maximum number of yards of material is 560 yards. Okay, so these are the two constraints. We have to determine some number of togas and some number of dresses using hours at 3 and 5 respectively, such that we do not exceed 500 hours, and some number of dresses using 4 yards and taking 5 hours each, such that we don't go over 560 yards in 5 hours each. And using these profit margins, live within the constraints, but maximize the profit. Okay, so here's how we do these. The first step, okay, is the objective equation. And the objective equation involves profit. Okay, so we're going to, at $55 each, get some number of togas. We don't know what that is yet. And we're going to add to that at $75 each, some number of dresses. The combination is, we use the Z for our profit or our objective. Sometimes we're looking at money now. It could be waste material, it could be a number of different things, but this one is money. And we're looking to maximize the money we make. Simple step one. And you can dig that out from the gross profits for the two products that are given in the problem. Step two. Okay, step two is write the constraint equations. Okay, we have two constraints here. We have a time constraint and we have a material constraint. Okay, so the time constraint is written like this. Togas take 3 hours. So 3 hours for each toga plus 5 hours for each dress cannot exceed 500 hours. Okay, I'll say that again. 3 hours for each toga and 5 hours for each dress cannot exceed 500 hours. Similarly, with the material constraint, we need 5 yards of material for each toga plus 4 yards of material for each dress, and that cannot exceed 560 yards. Okay, So there are our two constraints. Step 3. Graph the constraints. This is a good step because it helps you solve the problem, but it also gives you a good mental picture of what's going on here as well. So you don't have to be too precise with this. Kind of just arbitrarily, you can draw a graph. Okay, and we'll say that we're going to have, let's say, togas on this axis. It'll work if you do it on the opposite axis. Togas over here and dresses over here. Okay, so along the y-axis is some number of dresses. Along the x-axis is some number of togas. And we're going to try to get these constraints graphed onto there. All right, so we have a little trick for doing that. What we do is put a 0 in for togas. Okay, just assume we're not going to make any togas. If that becomes 0, then this drops out of it altogether. Okay, and the question is, if we make no togas, what is the maximum number of dresses we can make? Well, at 5 hours each, the maximum number we can make is 100 because we have 500 hours available. So one maximum point out here is 100 dresses. Say that one more time. If we make 100, no togas at all, and just 100 dresses at 5 hours each, we'll use up the 500 available hours. Do the same thing to get the maximum number of togas you can make. Throw a 0 in here to D. Okay, this disappears. And now we have to say, what is the maximum number of togas we can make at 3 hours each and 500 available? Okay, well, 500 divided by 3 is 166. Now, I truncated down if there's any fractions because you can't make part of a toga. Connect these lines. And what you have here is the time constraint. Any point along this line for corresponding to some number of togas and some number of dresses. So you pick a point right there, follow this over and follow it down. That's number of dresses, that number of togas. You will not exceed the time constraint. All points under the curve are feasible in terms of not exceeding the available 500 hours we have. All right, do the same thing now for the material constraint. Same trick. Plug a 0 into T here, make that disappear, and we have 4D cannot exceed 560 yards. Okay, we're at 4 yards a dress with 560 yards available. 560 divided by 4 comes to 60 divided by 4. We have 140. All right, and then same trick over here for D, put a 0 into D, and in this case, with this gone, the maximum number of togas we can make, using up 5 yards for each toga, 560 available, is 112. Connect these lines, and we have our material constraint. That's this line. Okay, so under this line, all points under this line are within the material constraint. So now, let's throw that onto the graph. Here, this vertically shaded area is okay for material. This horizontally shaded area is okay for time. The cross-hatched area is the points for which we're okay for material and for time. So this area under the two curves is referred to as the feasible region. Any point in the feasible region is permissible given the original constraints that we have. Now, the nice thing is that the optimal point will always occur at one of the corners. Well, this one too, in theory, that's a maximum point. Unfortunately, it's the maximum downward. Make 0 dresses and 0 togas. Yes, we will not exceed our constraints, but that's a trivial point that we're not interested in. So we have to test these 3 points. This point up here is a test for 112 togas and 0 dresses. This point is a test for 0 togas and 100 dresses. At this point, we got to figure out what it is. But let's get started on our candidate tests. T for togas and D for dresses. And over here is our gross profit. So as I was saying, one candidate to test is over here, 112 togas and 0 dresses. This point is 0 togas and 100 dresses. Now we need to get this point. To get this point, we're going to use a technique called simultaneous equations. Okay, and for simultaneous equations, we're going to start with our 2 constraint equations. Okay, now we have too many variables in here to solve for. Okay, we can't figure out what T and D is. But if we can construct a method for making one of the variables disappear, then we can solve for the remaining variables. Say we make the T's disappear, we can solve for D, and then we can use D back into one of these equations to figure out T. Let me show you what I mean. The first step to this is to get the coefficients of one of the variables. Let's target the T variable. You can do it with the D if you wanted to, but let's target the T. And get the 2 coefficients to be the same number. One trick that will always work for doing this is to multiply the coefficient of the second equation, use that one to multiply all the way through the first equation. And then use the coefficient of the first equation to multiply all the way through the second equation. If we do that, 5 times everything across here, this will become 15t. And if we multiply 3 all the way through here, this becomes 15t. And that's what we're looking for. 15t, we can make that disappear by subtracting the equations from each other. Okay, so let's try that. We'll multiply the first equation all the way through by 5. That will give us 15t plus 25d. See, each piece, multiply each part of the equation multiplied by 5. And 500 times 5 becomes 2,500. Okay. Then the 3, the coefficient from the first equation, multiplying all the way through the bottom one. That becomes 15t, which is what we were after, plus 12d, and that cannot exceed 560 times 3, okay, which is 1,680. And maintain the balance of the equation by treating each side of the, well, inequality in this case, the same. Multiply it all the way through by 5, all the way through by 3. And now here's the trick. If I subtract the smaller equation from the larger equation, smaller and larger being the numbers on the far side, okay, 15t minus 15t, bam, that's gone, that's 0. Plus 25d minus 12d, 13d. And that cannot exceed 2,500 minus 1,680, which is 820. 820. okay? We can solve for D now. 800, divide both sides by 13, and D is 820 divided by 13, okay? And that is 63. We got one of our points. With one of our points, we can now go back to any one of these equations we want and plug it in. Okay, let's take 3t plus 5 times 63, plugging d into, and you can use any one of these equations, not this one, but you can use these equations, doesn't matter. You can even use these if you want to. Okay, 3t plus 5 times 63, okay, and that cannot exceed 500, right from here, okay? So if you go ahead and resolve this, you'll find that t is going to be 61. T cannot exceed 61. And I'll let you guys do that. You can pause and give it a shot, but 5 times 63, and then subtract that from, oops, 500 there, 500, and then solve for t, divide both sides by 3. Now, it's 61.666 repeating, but you, again, you cannot make a portion of a product. So we'll truncate in this case. We're not rounding off, we're truncating. All right, so bam, we've got them. These are the numbers we needed. And if you look at it, D63, that's kind of not a bad drawing. And then over here, that's 61. Okay, well, I'm not the best artist in the world, but that's what these two mean. So we've got our last point at this corner to test for, and that's T of 61 and D of 63. Okay, testing these points, we're going to go back to our objective equation, this guy right here, and successively take each one of these candidates. 112 togas times $55, 0 dresses times $75, and what does that give us for profit over here? And we'll see what that profit is. Then we'll take the next candidate point, $0, 0 togas times $55, that'll be gone. And 100 dresses times 75, and then 61 and 63. Okay, so when you run through this, and you do the arithmetic, you'll find that the first option here is 6,160. I think I got that right. 6160. Yes, that is correct. 6,160. And again, that is 112 togas times $55 each. And this 0 times 75 just makes that 0. So that's really all you have to do. And then the second one is 0 togas. 0 here, that's gone. $75 times 100 dresses is $7,500. Okay. And then when you plug 61 into here, into T times 55, and add to that 63 times 75 and add them together, you get $8,080. Okay, bam, that's your winner right there. Tell the factory to make 61 togas and 63 dresses. You'll make $8,080 from that combination, and you will not exceed either your material constraint or your time constraint. Okay, thanks a lot. See you next time.